Welcome to part 4 of the chapter Coordinate System and Straight Line in Two Dimension. And we are discussing the chapter for preparation of JEE Main and Advanced and for different state level joint entrance examinations. Today, first problem is problem number 9 of that chapter, and the problem is the number of points on x plus y is equal to 4 which are unit distance from the straight line 2x plus 2y is equal to 5. Options are 4, 0, 2 and infinity. So that problem is very straightforward. Two straight lines are given and they are parallel. We have to find the number of points on that from which the distance of that straight line are unit distance. Unit, that means suppose this is x plus y is equal to 4. You see its gradient is y is equal to minus x plus 4, that is its gradient is minus 1. Similarly, its gradient is equal to minus 1, same minus 1. So they are parallel. As gradients are same, two straight lines are parallel. So this is second straight line, that is 2x plus 2y is equal to 5. Now, and because they are parallel, so taking any point on that, perpendicular distance on that straight line will be same for any points on that. They are same. Now, any point on that straight line x plus y is equal to 4 is, say, taking x is equal to alpha, so y is equal to minus alpha plus 4, that is 4 minus alpha. So it is any point on that. Once again, I'm telling that this is known as parametric coordinate of that point. Take any value of x, then find y in terms of that. So now, as because from the point say AB, distance from these two, say kx plus ly plus m is equal to 0 is k into a plus l into b plus m by root over of k square plus l square. Kl are coefficient of x and y. So from this point, distance between point is 2 into alpha. Oh, sorry. Just 1 minute. I am taking not in terms of alpha. I will discuss in terms of, suppose we take x is equal to 0. Then y will be equal to 4. So 0, 4 is a point on that, a particular point on that. Now from that point 0, 4, perpendicular distance on that straight line is 2 into 0 plus 2 into 4 minus 5 divided by root over of 2 square plus 2 square. It is equal to 0. 8 minus 5, that is 3 by root over of 8, which is not is equal to 1. So, distance from any point on it cannot be equal to 1 on that straight line as because they are parallel. So, second option, that is option B, is correct for that problem. Next. Next problem. It is problem number 10. Problem number 10 is, if C is a point on the line segment joining A minus 3, 4 and B 2, 1 such that AC is equal to 2 of CB, then coordinate of C is options 2 by 3, 1, 1 by 3, 2, 2, half and 3, half. Now in this problem, 2 points A is this point and B is that point B, they are given, and a point C lies within AB such that AC is equal to 2 times CB. Then to find coordinate of C. Of course, it is a very simple problem. Suppose this is capital X, capital Y. Now from this one, we get AC by CB is equal to 2, means 2 by 1. That is, very clearly, C divides the line segment joining A to B is in the ratio 2:1. So it is 2, it is 1. Now, very easily you can find the coordinate of C. X coordinate is equal to, it is 2 into X coordinate on the furthest point, that is 2 into 2 plus 1 into X coordinate of that point, that is minus 3, divided by sum of the 2 plus 1, which is equal to 1 by 3. Capital Y, Y coordinate, it is equal to 2 into 1 plus 1 into 4 divided by 2 plus 1, that is 6 by 3 is equal to 2. So, coordinate of the required point C is 1 by 3, 2. So, option B is correct here. Second option is correct. Next. Problem number 11 now. It is, if C is reflection of A coordinate is given 2, 4 on x-axis, and B is reflection of A, B is reflection of C on y-axis. A given, so C is reflection of A on x-axis and B is reflection of C on y-axis. Then find distance of AB. Options: 12, 18, 5 root 3 and 4 root 5. In that problem, one point is given. Suppose this is x-axis, this is y-axis, and a point A is given as 2, 4. C's reflection of A with respect to x-axis. So C's reflection of the point A with respect to x-axis. So if this is perpendicular is drawn, C is the point here such that its distance from this and that are same. That is, this distance is 4 and x coordinate of that point remains same as A. So it is 2, minus 4 because it is on negative side of y-axis. Now from C is B is the reflection of C with respect to y-axis. Suppose B is there. This is B. Now, and because this perpendicular is drawn on it, this distance must be equal to that distance. Now, x coordinate of C will be equal to minus 2 because it is 2 in positive side of x-axis, this is 2 on negative side of x-axis, so minus 2, and y coordinate of C and B remains same, that is minus 4. So coordinate of B is minus 2, minus 4. From there you can always take if C is reflection of A and B is reflection of C, then coordinate of B will be minus 2, minus 4. One on x-axis, one on y-axis. So distance AB is equal to root over of 2 minus plus 2 whole square plus 4 whole square. 4 minus 4. So that it is equal to root over of 16, 64. So root 80, it is equal to 4, that is 16 into 5. So 16 is 4 here outside square root into root 5. So 4 root 5 is the required answer. So this is answer. Option D. Next, problem number 12. So problem number 12, and the problem is one possible condition for 3 points A, B, B, A and A square minus B square to be collinear is options A minus B is equal to 4, A plus B is equal to 3, A minus B is equal to 1, and AB is equal to 2. The problem is 3 points AB, BA and A square minus B square. These 3 points are collinear, means they are lying on same straight line. In that case, we have to find the condition, and 4 options are there. And because 3 points are collinear, then we can say that their area of the triangle formed by these will be 0, or we can say if these points are collinear, say it is A, this is B, this is C, A, B and this is C, then in that case we can say that gradient of that part AB and gradient of BC must be same because they are part of same straight line. Now gradient of AB it is equal to A minus B divided by B minus A, that is minus 1. Now gradient of BC minus B square minus A B square minus A by A square minus B. So they are same. Gradient of AB minus 1 and this is. So from there we can say that B square plus A by A square minus B is equal to 1. I cancel negative from this and that. By cross multiplication, B square plus A is equal to A square minus B. So B square minus A square, another A square minus B square, A square minus B square is equal to A plus. Now this is A plus B into A minus B, taking A minus B zero, taking A plus B into A minus B minus 1 is equal to 0. So our answer is either A plus B is equal to 0, first factor 0, or second factor 0. For second factor, A minus B is equal to 1. Now question is one possible answer. This is possible answer, this is also possible answer, but this is not given in the option. So this is given. So this one is correct option, that is option C is correct. Next. Problem number 6. Sorry, not problem number 6. It is now problem number 13. The problem is the distance between two straight lines, height x minus 12y plus 65 is equal to 0 and height x minus 12y minus 39 is equal to 0. You see, these two are parallel straight lines because its gradient n is equal to 5 by 12. Its gradient also 5 by 12. So they are parallel. And for any two parallel straight lines, to find a perpendicular distance, it is wise to take any point on it, any point on that. Say this is any point, and by choosing, and because 5 into 13 is equal to 65, so we take 13 comma 0 is any point on it. 13 0, so 5 into 13 is 65. Oh, minus 13, sorry. This is minus 13. Just 1 minute. I check whether I have copied it correctly or not. Okay. 5x minus 12y plus 65 0. 5x minus 39. Okay. So we take minus 13 comma 0 is any point on that because it satisfies it. So its perpendicular distance from that point is same from any point to that, any point to that. So we have to find the perpendicular distance from this to that. It is equal to, actually it is that straight line. So it is equal to 5 into minus 13 minus 12 into 0 minus 39 by root over of 5 square plus 12 square is equal to 60 minus 65 minus 39 by root over of, it is 5 square plus 12 square is nothing but 169 is equal to 14. Now distance cannot be negative. That's why we have to give one modular sign. So it is equal to 104 by 30. It is equal to 8. So answer is 8. Oh, options not yet given. Anyway, options I am giving. Options are 8, 5, 4 and 13. So this option is correct. So this is one way for obtaining distance between two perpendicular straight lines. Another very simple way is there. You have to keep in mind in that case, if they are parallel, then the distance between two straight lines if the constants are of same sign, here it is different. If same sign, then you take, suppose this is plus, then you take 65 minus 39 by root over of this 5 square plus 12 square, that is 30. If they are of opposite sign, as in this case, then the distance between two straight lines at once we can obtain by 65, and because it is negative, so minus of minus 39 divided by root over of 5 square plus 12 square. That is, it is 104 by 13. And before calculating that, one thing we have to consider that coefficient of x, coefficient of y must be same for both the cases. It may be so happen it is 10x minus 24y minus 39 is equal to 0. They are parallel. These are that, they are parallel. But coefficient of x is 5 here 10. Coefficient of 12 is minus 12. that is minus 24. They are not same. First of all, we have to make coefficient of x and y for both the straight lines must be made same. After that, if they are of opposite sign, then answer will be this plus that divided by root over of this square plus that square. Okay. Let us stop today. Next day we discuss few more problems. Many problems I will discuss, and I request you to share, like and subscribe my channel. Thank you.